Welcome to our Fresh Thinking podcast. Today's topic is where geology meets engineering, the role of the geotechnical core logging. My name's Hamish Guthrie, Managing Consultant with Snowden Optiro. Today we're joined by Ezilma Diaz, our Principal Geotechnical Engineer with more than 18 years of experience in both Brazil and Australia. Her work focuses on rock mass classification, geotechnical modelling, stability assessments for both open pit and underground operations. Today she's sharing her insights on why geotechnical core logging plays such an important role in mining design and risk management.
It's my pleasure to be here to sharing some professional experience.
For listeners who may not be familiar with geotechnical work, what exactly is geotechnical core logging and why is it important in mining projects?
Geotechnical core logging is the process of understanding how the rock mass will behave when we mine it. One important distinction is the difference between geotechnical and geological core logging. Geologists typically focus on lithology, alteration, and mineralization because they want to understand the ore body. Geotechnical engineers focus more on the mechanical behavior of the rock mass, structures, defect conditions, and rock mass quality. Conditions that ultimately controls stability and design. The most robust geotechnical model usually come from strong collaboration between geologists and geotechnical engineers because geological understanding provides the context and geotechnical interpretation translate that into engineering behavior. Before any slope is designed or any stope is mined, the first step is to understanding the rock mass through core logging. When we log geotechnical core, we are looking at several key elements. First is lithology, which provides important context for the rock mass. Then we focus heavily on structures, joints, shears, faults, bedding, or foliation, because these discontinuities often controls stability. We also record rock quality parameters such as RKD, fracture frequency, strength indicators, and defect conditions like roughness in fill and weathering. Identifying patterns in these structures help us define geotechnical domains and understand how the rock mass may behave during mining.
And Ezilma, from your experience, how does the quality of core logging influence geotechnical design and risk management?
Core logging forms the foundation of the geotechnical model. That model feeds directly into design decisions such as slope angles, stope spans, pillar design, and ground support requirements. In geotechnical engineering, uncertainty in the rock mass translates directly into operational risk. So the quality of the data we collect during core logging is fundamental. Good geotechnical engineering doesn't start with modeling software. It starts at the logging table. So when logging is done well, it allows us to define domains, understand the structural controls, and apply rock mass classification system such as Q or RMR with greater confidence. Those parameters feed directly into stability assessments, numerical modeling, and support design. In many ways, core log is one of the earliest opportunities we have to reduce geotechnical risk in a mining project.
They're very important. What are some of the common mistakes or challenges you see when logging occurs?
Over the years, there are a few common issues that can affect logging quality. One is the logging too quickly and missing important structural features. Another is inconsistent RKD measurements, especially when broken core pieces are fitted back together. Structural descriptions sometimes lack detail. Things like roughness, infill, or weathering conditions can significantly influence stability. Consistency between loggers is also critical because if the same core is described differently by different people, the data set becomes difficult to interpret.
And Ezilma, did you have an example from your experience?
Yes, in one of my geotechnical review for an underground mining project, the team actually had a large amount of drilling, diamond drilling, and geotechnical core logging on paper. The data set looked very strong. The rock mass classification results suggests good to very good rock mass conditions. And based on that interpretation, the project had selected the long hole open stoping as the mining method. But during review, I compared the core logging database with the core photographs, and something it didn't match. The photos clearly showed intervals of very fractured and broken ground, yet those intervals had been recorded as simply as no applicable in the logging database. In practice, only the competent rock had been logged properly, while the weakest ground had been completely ignored. As a result, the rock mass classifications appear much better than the actual ground conditions. Once this discrepancy was identified, I became clear that the geotechnical model required refinement, and the suitability of the selected mining method need to be reassessed. For me, it reinforced a critical lesson. In a geotechnical engineer, it's not just about having data, it's about having data that truly represents the ground. Sometimes the biggest risk in a project is not the absence of information, but the false confidence created by incomplete or biased data.
No, a good example. How do you see core logging evolving in the future with new technologies?
The future of core logging is evolving quite quickly with new technologies. We are seeing increased use of digital logging platforms, high resolution core photography, teleview data, and even automated fracture detection using image analysis or artificial intelligence. These tools can improve consistency and data quality for sure. However, technology will continue improving how we capture data, but the real value still comes from experienced professionals interpreting the rock mass and understanding how it will behave during mining.
Exactly. What advice would you give to geologists or early career engineers involved in core logging?
For geologists or early careers engineers involved in logging, my biggest advice will be to take the time to observe carefully and describe what you see clearly. Understanding defects conditions and structural patterns can significantly improve the quality of the geotechnical model. Even small improvements in consistency and detail can make a big difference to the reliability of the data used in the design. And I think my message would be call logging may seem like a routine activity, but is actually one of the most important foundations of the geotechnical engineering. Every slope angle, slope design, and ground support decision ultimately starts with observation made at the logging table. And good logging leads to a better models, better design, and ultimately safer and more efficient mine operations.
Thank you, Ezilma. Thank you for your insights. Thank you. That brings this podcast to a close. If you enjoyed it, please subscribe, like, and share. We look forward to bringing you more fresh thinking podcasts. If you'd like more information, please check the notes section of our contact details.